Hello and welcome to this video on how to make a flames effect in Unity shader graph. As you can see here, there's loads of uses for this effect, from jet engines to campfires to magical orbs. I'm going to be using Unity version 6.1.5 for this project, but you should be able to follow along in pretty much any version. So to start off, we're just going to create a quad, and then we're going to position our camera to be looking at that quad, and this is just going to be the mesh that we put our effect onto. Then we're going to want to create our shader graph, so right click, go to create, shader graph, URP, and we're going to be doing an unlit graph, and just name it something like fire. Next, you're going to want to create a new material. Make sure your material is using your new shader graph you just made, and then assign the material to your quad. And there we go. Now we're ready to start creating our shader. Let's open up the shader graph. Now the first thing we're going to want to start with is some noise, as most shaders do. We're going to use gradient noise, and we just want to plug this straight into the base color so we can see it on our mesh. That's looking great. Now the next step is to make our noise move. For that, we're going to want to add two new parameters. The first is a float parameter that we're going to call speed, and that's just going to be the speed at which it moves. The second parameter is going to be the scroll direction, and this is going to be a vector2 parameter that controls which direction the noise moves in. Now we're going to create a time node, and we're going to multiply the time by our speed parameter to speed it up by the amount that we specify. Then we're going to multiply the output of that by our scroll direction. And finally, we're going to put it into a tiling and offset node in the offset section. So it's going to offset our noise by the speed and direction that we specify. And we're going to put that in the UV of the gradient noise and set a default value for the speed and the scroll direction. I'm going to set the default to a kind of slow scroll that goes upwards, because that's most similar to fire. Now quick tip, if your shader's looking very laggy in your viewport, it might be because you don't have always refresh turned on. So if you go up here and on this drop down select always refresh and make sure that's enabled, that's going to make your shader look a lot smoother within the viewport. It won't have any effect on the actual game. So the next thing we want to do is create a wavy effect to the top of our fire so that it's not just a square. For this, we're going to create a UV node, and you'll see that each colour on the UV node represents a different direction. So if we split off the Y direction, or G, we'll see that it's a vertical gradient with the brightest pixels at the top. And then we're going to create a parameter called flame height, which we'll plug into a power node to influence how high the fire goes. And now if we multiply what we just did with our original gradient noise, you'll see that it's beginning to look a lot more like fire. Something we need to do is turn this into a transparent material. So if you go into the graph inspector here, down to surface type, and set that to transparent, then you'll see that alpha and alpha clip threshold appear on our output. We want to use our main colour also as our alpha for now. And there you go, you'll see that this already looks a lot more like fire or smoke because of the added transparency. Currently, our fire effect just scrolls straight up and lacks some of the smaller detailed movements that a real fire would have. So to aid that, we're going to add a second kind of noise. We're going to create a second parameter called scroll direction B. Make sure you rename your other one to scroll direction A, as we now have two. And we're going to want a similar setup to what we had before, where we multiply our time by the scroll direction. We're going to want to create a Voronoi noise, which is a type of noise that has a bunch of cells of different gradients. Next, create a tiling and offset node and use it as the UVs for our Voronoi. Unity has a built-in node called a twirl node. Let's use that as our UV for our tiling and offset. You can see that as we use the twirl node to sample our Voronoi noise, you get this lovely wavy effect. However, this alone isn't quite what we want, so we're going to actually make another gradient noise node. Currently, this gradient noise is between 0, which is black, and 1, which is white. We're actually going to want to remap this noise node so that instead of between 0 and 1, it's between something like 2 and 5. Then we're going to use it as the angle offset for our Voronoi. This means that the angle at which the noise is offset changes based on the gradient noise. This gives us a really lovely sort of heatwave effect once we add in the UVs from our twirl node. Next, we're just going to multiply this with our original noise to get a much more complex fiery shape. Looks like the alpha is set a bit too low at the moment. This is because the alpha clip threshold is high, which means that anything below that it will just not bother drawing at all. So we'll set that a bit lower so we can see more of our fire. Now it's time to add colour to our fire. We're actually going to have 3 colours, so we're going to want to create 3 different colour parameters. We're going to have one colour as the background, one colour for the midtones, which I'm going to call the base colour, and then one on top for the highlights. I'm going to give these defaults of a kind of dark red for the background colour, a orange for the base colour, and that classic yellow for the highlights. For the red, which is the background, it's very simple. We're just going to get a multiply node and multiply the noise that we have already with our background colour. For the other 2, we're going to want to highlight the brighter pixels of our noise, and for that we're going to use the smooth step node. So using this node, we can isolate only the brightest pixels, and then in this case we're just going to multiply the result of that by our midtone colour, and we're going to do the same for our highlights and multiply it by our highlight colour. But for the highlights, we're going to set our edge 1 higher so that it isolates even brighter pixels. Then we're just going to add all of the different colours together to get a nice fleshed out fire effect. Before we plug it into our base colour, we're going to create a quick float parameter called brightness, and we're just going to multiply it by that as a kind of overall value to easily allow us to go in and change how bright our shader appears without having to change each individual colour. So now we're just going to sort out the alpha a little bit on our flame effect. We're going to create 2 parameters, both floats, called alpha and alpha clip threshold, and then instead of just splitting off the alpha from our main flame effect and plugging it straight in, we're going to first multiply it by our alpha parameter we just made and then plug it back into the output. For the alpha clip threshold, we're going to take the alpha again and multiply it by the alpha clip threshold, and that's that, all done. Also, something that's important to do is get a maximum node, and before getting our final flame effect into the base colour, you want to run it through the maximum node. So this means that if somehow you ever end up with a negative number in a shader effect, it just caps it so that it can't go below 0, because having negative numbers as the output of some shaders looks very strange, it causes some strange effect. So you want to minimise that, and this is an easy way to do that. Next we're just going to sort out our parameters a bit, because we have quite a lot of them now. We're just going to create categories for each section. For example, I'm going to have one category with all of the colour parameters in it, and another one that has all the parameters that affect alpha in it, etc. You can organise these however you want, as long as you find it easy to work with. So our effect is looking great on our quad here, but what if we wanted to put it on a different shape, say a cylinder for like a jet engine or a campfire effect? I'm going to get a cylinder in here, and I'm just going to chuck it next to our quad, and I'm going to chuck our material onto it. So it looks great as well, but then you look at the top and you see, oh, there's fire on top of the cylinder. That's not supposed to be there, and there's also fire underneath. So we need some way of ensuring that our shader isn't going to be drawing the material on the top or bottom of an object, it's only on the sides. So to do that, we're just going to create a normal vector node. It's kind of like a UV node in that each colour represents a direction, except this is in object space, not based on the UVs of your mesh. If we split off the Y direction from it and put that into a smooth step, you can see that by editing this edge 1 here, we can control how much of the top of our model we're cutting off. And if we negate that value and stick it into another smooth step, we'll instead be cutting off the bottom of our object. So if we just add these together, you can see that we're masking off the top and bottom level of our object. Now we want to put that into a 1- node, and I'm going to group it all together and say, oh, this is for colouring the top and bottom faces, just to be nice and organised. And then we want to multiply this in just before we separate it out into the colour and the alpha. And make sure you plug it into the colour and the alpha. And there you go. Now the top and bottom will be cut off of our cylinder. So that's pretty much our effect complete. You've got a lovely fire effect with 3 different colours, it's got transparency, and it cuts off the top and bottom of our material so that it doesn't look wrong. Now I'm going to go through a couple of extra things you might want to do. So if we go in our graph settings here, we might want to turn cast shadows off because fires don't usually cast shadows, and we can also set the render face instead of just being the front to both if you prefer. This means that it will stop culling the back faces of our mesh and you'll be able to see the fire through itself. Personally, I go back and forth on whether this looks better. I'm going to leave it on front for now. What we can also do in the colour parameters within our shaders is set the mode to HDR. This is going to change the colours and how they look, and basically it allows us to very easily have bloom on our fire. It means that brightnesses above 1 automatically have bloom kind of effect applied to them to show that they're really bright. So adding bloom is really going to make your fire pop, so if you want to just create a post-processing volume and put it on your camera, set up a profile with some bloom, and make sure to enable post-processing on your camera as well. Now one extra thing I'm going to add on the end here is if you wanted a more cartoony fire effect. What you can do is very simple. Instead of using smooth step nodes in your graph, just replace them with step nodes. So basically it's just what it says on the tin, it's like a smooth step node but less smooth. It's only got one edge and it just creates a hard cut, and anything out of a step node is only going to be black or white, there's no grey. You might need to tweak your colours a bit and your brightnesses, and you're going to want to add a step node to your background as well. And there you go, you can see that this makes a more cartoony, kind of cell shaded almost fire effect. If you made it this far in the video, thank you for watching. I hope you found this video helpful, and if you did, please feel free to leave a like or a comment.